So I'm Varsha. Currently we are starting with the module 1 of BDA, that is Big Data Analytics module 1. So in case if you need any other module from any other subject, kindly comment it down below so that it will be helpful for me to decide which module should I take up next. So starting with this module, here in this module you will learn about what is this big data, how to process it, and different kinds, types, etc. So let's start with this big data module. So here in this introduction of the big data, you will learn what is the need of the big data and how it is processed and etc. So now let's start. So why do we need this big data? So the need is highlighted here. The rise in the technology has led to the production of large and then voluminous amount of data. That is, so the data being generated day by day is extremely voluminous amount of data. In the earlier days, the data was about 10 power 6, and now the data is generated up to 10 power 15. Like after one you have 15 zeros. Just can you imagine how much data is being generated? In order to process that, in order to do the calculation, or in order to get the result, we use this big data analysis. So here you have comparison regarding how the simple data is being converted to the big data. That is, from normal unstructured data, we are getting complex and unstructured data type, and in earlier days we used to get megabytes of data. Now we are getting petabytes of data. So that is how the difference is being generated nowadays. And now, so the characteristics of this simple querying or structured the traditional data is the example of simple querying RDBMS. But in this the stock characteristic of this big data is nothing but a volume, velocity, and then velocity and variety. These are the characteristics of this big data. So you will learn more about this in the next in the upcoming slides. So yeah, let's start with this big data. So big data is nothing but usually in the form of facts or statistics that can analyze or use for a further calculation. The official definition will be learned in an upcoming slide, but now, as of now, it's just a data or information, usually in the form of stats or facts, that can be used for a further calculation. So there is a difference between normal data and very big data. Correct. So normal data is nothing but the size or the amount, the volume of being generated is less, whereas the big data, where the volume or the amount of the data being generated is very, very high. And we have different forms of data, and the one form is that web data. Web data is nothing but a data present on the web servers or enterprise servers in the form of text, image, videos, and then audios are nothing but a web data. The data which is stored in the website or any other any web server is nothing but a web data. Here the client can access the data, that is pull the information from the data, that is from the server, and can also publish the data that is push, or even post the data to the server. So these are all the different types of operation that can be performed on the web data or web server. So the example of the web data is nothing but Wikipedia, you know about this, and Google Map, YouTube, Facebook, and you are daily using this web data, and you are also one of the reason for creation of this web data, correct? So and the next we have different types of classification, that is semi-structured, structured, and multi-structured, and even unstructured types of data. These are the different types of data that is used. First, let's see what is the semi-structured of data. So semi-structured data is nothing but which is associated in the form of schema and then data models. Schemas and then data models. So structured data found in the form of tables and rows and then column. So in a regular DBMS, you have learned regarding the data being stored in the tables, that is rows and columns. That is nothing but the structured amount of data. The overall data being generated is nearly 15 to 20% of data is structured or semi-structured data. So that much of structured and semi-structured data is being generated. And the next, here we can insert, delete, append, or even indexing is easy, enable the faster data retrieval, and scalability can be done, and transaction process, that is ACID properties, will be applied, and even encryption and decryption for the data capacities, data security is done. And the next, coming to the semi-structured data, here the data is nothing but in the form of XML and then JSON. Here, it contains the tags or other marker which separate semantic element and enforce hierarchies. So semi-structured is nothing but which is in the form of XML or JSON, XML and JSON document. Here some tags or other markers is used to separate the semantic elements. And the next, multi-structured of data. Here the data being generated consists of depends or belongs to different types of category. That is, it may be structured, semi-structured, or even unstructured data together being generated is nothing but the multi-structured data. And the next, we have unstructured data. It does not possess the features such as table or the database. Here, the data cannot be processed or data cannot be stored in the form of table or any such kind of data. It cannot be possible to store. So, unstructured data found in the form of files such as text or .csv file. This is nothing but the unstructured data. And so here the unstructured data can be stored in the form of key value pair, and unstructured data is an example are nothing but the mobile data, web content data. So these are all the example of key value pair. In turn, it's nothing but the data being generated of unstructured. So, and the next, as I said before, so we have a proper definition for a big data. So if you want me to define what is this big data in a proper assigned or in a proper technical terms, so we define a big data as high volume, high velocity and high variety information that requires new form of processing for enhanced decision making inside discovery and process optimization. Here the high volume, high velocity or high variety of data being generated that requires a new form of processing in order to enhance the decision making and inside discovery and then process optimization. That is nothing but the big data. So that is the definition of this big data. And the next, characteristics of this big data. As I said, there are four V's. That is volume, velocity, variety and even veracity. So what does it mean? The volume, as the name says, it's related to the size of the data, that is how much data is being generated, that is the volume of data. Velocity, it's nothing but the speed of generation of data. Variety is nothing but variety, that is different types of data that is being generated. In veracity, that is quality of the data that is captured. This is the characteristics of the big data. And the next, so big data types. So what are the types, or where the big data or the data is being the types of data being generated? One is social network and then web data. Second was transaction and then business process data such as credit card details, flight booking, etc. And even consumer master such as data for facial recognition, for the name, date of birth, marriage anniversary, gender, location. These are all the customer master data. And the next one is machine generated data, that is IoT data or any other data from the sensors. These are all the machine generated data. Computer generated data is also considered as machine generated data. Human generated data such as human machine interaction data, emails, messages and browsing history, everything is in human generated data. And human also record their experiences, writing these notebooks in diaries, taking photographs, audios, video clips. And human sourced information, that is entirely digitized and stored every day. So these are all the different types of big data that is being generated each day. It may be social network or the web data such as from the Facebook, or it may be credit card details, flight booking, that is transaction data, and a customer master data, that is gender, location and income category. Machine generated data, customer generated, computer generated data, human generated data. Human also record their experiences, human sourced information. These are all the different types of data that is being generated. And the next we have big data classification. Here we classify the big data. So the classification of big data is done in the following ways. I hope this is visible. I try to fit this in single window. Yeah. So big data classification. The big data is classified as the data source data format, big data source big data format, data source structures, pre-processing data rates, analysis types, and one more is there. So here it is compared with the traditional method, that is relational or RDBMS, these traditional method with the big data. So this is how the big data classification is made. And then next, so first let's begin data source. So what are the types of data we can get it from the traditional database? Traditional database, it's not traditional data is nothing but a small data which can be operated with the help of table or a structured or even schema. That is, a relational database can be the example of traditional database or traditional storage, traditional data. So first, data source. What are the source of data for traditional data? So when it comes to this, when we come to the data source for the traditional method, we have distributed database, RDBMS, column oriented, in memory table, and data warehouse, etc. These are all the different sources for the traditional data. And data formats of the traditional data is nothing but semi-structured and then structured, as I said before. And big data, when we come to the big data, big data source is nothing but the data storage distributed file system, and the NoSQL, that is MongoDB and Cassandra, sensor data, audit trail, etc. These are all the big data information. And the next, moving on to the next, that is big data format. So for traditional data format, we have structured and semi-structured, but for big data format, we have unstructured, semi-structured, and even multi-structured data. And the next, data store structure. Here we use web enterprise cloud servers, data warehouse, row oriented, that is all the structures we use. And data processing rates. So the processing of this data is nearly batch, near time, or real time, or even streaming. This is the data processing rates. And data processing of big data rates is high volume, velocity, variety, veracity, batch, real, near time, and streaming. Including the features of this additional new features is added to this big data rates. And analysis of reports, that is batch, schedule, or near. And big data processing methods, we use MapReduce, Hive, Peg, etc. And data analysis models, we use status analysis, predictive analysis, and regression, Mahout, machine learning algorithm, etc. And next, data usage, we use this data for human business process, knowledge discovery, and enterprise application and data. So this is the data classification. So I'll just minimize it, hope you can see. So data source, data format, big data source, big data format, processing data rates, processing big data rates, and big data processing method, data analysis method, data usage, and then data structure stores. These are the different big data classification. If you are referring to these notes, then make sure that the heading is just below this one, that is big data classification information is given here. So yes, moving on to the next concept, that is big data handling technique. So how to handle this big data? There must be some technique in order to handle this big data, correct? Since the data is very huge, we need to handle it carefully. So the techniques of handling is huge data volume storage. So huge data is being generated, thus that should be data distributed and high network, and then high performance computing should be there. Application scheduling using open source, reliable, scalable distributed file system. Open source tools such as which are scalable, elastic, and provide a virtualized environment. And data management, NoSQL, document database, and column oriented is used. And data mining analytics, data retrieval, data reporting, these methods will be used in order to data mine. So these are the techniques given for storage and opening, and even tools, data management, and even data mining. So these are all the features given to that. And the next one is scalability and then parallel processing. Scalability is nothing but increasing or decreasing the features or the number of size. So that is nothing but a proper scalability. Parallel processing is nothing but performing two different tasks simultaneously. Nothing but a parallel processing. Let's see what it is. So in scalability, here you have we have two types, that is vertical scalability and horizontal scalability. Vertical scalability, it's nothing but increasing the system's analytics, reporting, and visualizing capabilities. That means it is increasing the properties or the enhancing its feature is nothing but vertical scalability. Whereas in horizontal scalability, we increase the number of the system working in coherence and scaling out the workload. So vertical scalability, here we increase the features, but in horizontal scalability, here we increase the number of the computers being generated, number of computers of the system working in coherence, that is working correlated to each other. That is nothing but scalability. And then parallel processing platform. Parallel processing, it's nothing but, as I said, so two tasks working or simultaneously is nothing but the parallel processing. Here distributing the task, how can it be done? So it can be done at several different levels, that is a separate task onto separate threads on the same CPU, separate CPU on the same computer, onto the separate computer. We can distribute the subtask onto the same separate threads on the same CPU, or separate CPUs on the same computer, or even on the same computer, or even on the separate computers. So these are all the massive parallel processing techniques. So and the next we have distributed computing model. And the next we have a distributed computing model. Here the processing is done at a distributed level. So that's it. You will learn about this more in the next slide. And the next one is cloud computing. Cloud computing is nothing but internet based computing that provides a shared processing resources to the and data to the computers, other devices on demand. So on-demand services is provided in the cloud computing. So the features of this cloud computing is nothing but on-demand services, resource pooling, scalability, accountability, broad area network, and then cloud services. That is, it can be accessed from anywhere at any time through the internet. It's nothing but the features of one of the feature of the cloud computing. There are three services provided by this cloud computing, that is IaaS, PaaS, and then SaaS. So let's see what it is. IaaS means infrastructure as a service, platform as a service, and software as a service. So and then first we'll looking into the IaaS, that is infrastructure as a services. It provides the infrastructure such as hard disk, network connection, and database storage, data center, and visual server. These are the service provided by the service providers. So if you provide these features or these services, so then we can say it as infrastructure as a service, and the rest, that is platform or a software building, should be looked after by you. So you need to take after that. So only the hard disk and the database storage, data visualization will be given by the service providers. And moving to the next concept, that is platform. Here the platform, that is providing a runtime environment to allow developers to build an application and services. Here platform is given. With the help of the services, in addition to the IaaS, they provide a platform to run or to build an application. So that is a platform. Example is that Hadoop cloud service and Oracle Big Data Cloud Service, they provide a platform as a service. That means they provide an environment where the developers are allowed to build an application. So that is nothing but a platform as a service. Software as a service, it's a service to an end users. So to complete software or complete package or some complete package of software is being developed by the service provider, that is known as a software as a service. Here for example direct app will be developed, the user just need to use it, that's all. It can be directly given to the customer. So that is nothing but software as a service. And next one is a grid computing. This refers to the distributed computing, in which a group of computers from a several location connected with each other in order to complete or in order to achieve a common task. For example, here you have different computers, say this is A and B. I have one problem, I need to calculate x plus y. So x will be given to this A and then y will be given to this computer B. Together the results will be calculated and given the output will be generated, for example Z. So this is nothing but the grid computing. Here, in which a group of computers from several locations are connected with each other in order to achieve some common task. This is nothing but the grid computing. And clustering computing, here group of computers are connected by a network. They group work together, accomplish the same task. Mainly this is used for a load balancing. In order to balance the load or the pressure for that system, we use this cluster computing. And the next one we have volunteer computing. Here a volunteer provide computing services to projects of importance that uses a resource to do the distributed computing or storage. Say for example, you don't have, whenever you need to calculate some value, you don't have enough resources, volunteer computing or the volunteer computers come to help us. So they will take the they will give the resources, or they will do the computing, or they will do the storage services will be provided by this volunteering computing. And the issues with this volunteering computing are heterogeneity, dropouts from the network over time, they sporadic availability. So these are the issues with the volunteer computing. And the next one, we have design of this big data architecture. So for designing a big data architecture, we have 5 different steps, that is identification, acquisition or ingestion, data storage, data processing, and data consumption. Say for example, you have food. Take a scenario where you eat the food. So that is a scenario. How can we divide that into different parts or different layers? Is first you identify what you have, correct? So and the next you will extract, or you will inject, or you will acquire the items available for that food, and you will include all these ingredients to the vessel, that is you're storing that in your vessel, and you will cook it, that is you will pre-process it, and you will consume it later, correct? Similarly, in data processing also, we have divided this architecture into 5 different layers. That is, first is identification of data source. First we identify the data source, and then we acquisition, ingestion, and extraction will be done of that data, and data storage will be done, data processing will be done, and the next data consumption in the number of programs is done. That is nothing but the data processing architecture. So this is how the diagram looks. Here you have 5 different layers, that is layer 1, layer 2, layer 3, layer 4, layer 5. So I will give an example how to write this. I will give a trick how to write this. So first you need to add these 5 layers, that is 5 boxes. Don't forget to add these 5 boxes. Once you add this 5 axis, add 3 box, 3 box, 3 box, and then 4 box. So you need to fill. So you're okay with the framework. Now we need to fill the data. As I said, first what we will do, we will identify the source of data, and the next we inject ingestion, and then acquisition will be done. We store the data pre-processing will be done, data consumption will be done. So first source, this will in the first layer 1, that is the layer 1, that is source of in the layer 1, source for ingestion of data, and the next we push or pull the data from, and the data types is identified, and data formats is identified. In layer 2, the important point is pre-processing. So pre-processing is a very important step in this data 2, that layer 2, that is data ingestion and then acquisition. So here we ingestion using the ELT, that is extract, load, and transform, and we extract the data semantic, and we do the data semantic, and pre-processing is done, ingestion of the data is done. And then next layer 3, that is data storage. So here we can use formats, consideration of types, it depends on them, and we can use the distributed file system in order to store the data, or also you can use the NoSQL data in order to store the data. And the next data processing. So data processing technique, that is map reducing, Hive, Pick, Spark can be used, and processing in real time should be done. Asynchronous and then synchronous processing should be done. Now we need to data consumption, that is we need to export that to the cloud or web, or you need to use that. So that is export to the dataset usage, or analytics, that is visualization and reporting. So this is how this architecture is designed. So here you have a definition regarding all this layer 1, layer 2, layer 3, layer 4. You can go through it. And the next, you have managing data for analysis. So how can we manage the data for this analysis? So first, managing data for the data analysis. So we have different data management functions while managing the data, where there are various functions we include, that is data assets creation, maintenance, and protection, data governance, data architecture creation and then modulation, database maintenance, managing data security, managing the data quality, data collection using the ETL, that is extraction, transform and load, managing the data documents, creation of reference and master data, data application and integration, data integrated management, data warehouse management, maintenance and then business intelligence, and data mining and then analytics algorithm. So I will just zoom it out. Oh yeah. So now, so data asset creation. So from point 1 here you have data asset creation, data governance, data architecture creation, and maintenance. So maintaining the database is very important, and data security is also important, managing the data quality and data collection. So these are all the various steps involved. So consider that as an data management and data management function. And next you have data application integration, integrated data management, data warehouse management, and maintenance of business and intelligence. So that is nothing but the managing data for analysis. So you can write it on own because it's just a simple general knowledge thing about the managing the data. So since you are a CS student, you can write it on your own. And the next we have already discussed this types of data and everything. So maybe moving on to the next concept, that is data quality. So what is this data quality? How can we say that the data is very high quality data has very high quality data? So how can we say that? So which enables all the required operation, that is analysis, decision, planning, knowledge, discovery correctly. So we can apply all this knowledge and we get the output correctly, then we can say that the data means the data has the high quality. And 5 R's as follows. So relevancy, recency, range, robustness, reliability must be there for that data. So then only we can say that data has a very high quality. So there are different factors that affect the data quality, that is data noise, outlier, missing values, and then even duplicate values affect the data quality. And so here you have a brief introduction about that. And the next one, data pre-processing. So once you have the error or the low quality data, you need to pre-process it, and you need to enhance it, then only you can process it, then only you can use it, correct? So first the data pre-processing is done. Data pre-processing is nothing but it's a very important step in the ingestion layer, that is layer 2. I said data pre-processing is very important in the ingestion layer, that is layer 2. So must be done before data mining and then analytics. So pre-processing done. So what do we do in this pre-processing? Is nothing but we drop out the range or inconsistent outliers. For example, you have these are all the graph points. Say for example, these are all the graph points you have, and you have few values here outside the graph. So what you will do, so you will consider these values, you will remove this extra or unrelated data. So that is nothing but dropping out of range, inconsistent and outlier values. So that is nothing but dropping that value. Filtering and irrelevant, redundant information. Data cleaning, editing, and data validation and ETL processing. That is done. And the next. So the next step is data cleaning. Data cleaning refers to removing and correcting incomplete, incorrect, inaccurate, irrelevant parts of data. So that is what we do in data cleaning. And data enrichment refers to operation or process which refine or enhance or improve the raw data. So here we improve the raw data. For example, some values may be inaccurate or not related. So then we will make it more accurate, and we enrich the data which improve the raw data. And editing methods are interactive, selective, automatic, and aggregating and distribution. These methods is used. And the next, data reduction. So here we enable the transformation of acquired into the correct and simplified form. So that is the next one. And the next one is data export to the cloud. How can we export this data to the cloud? So the showing result of data preprocessing, mining, and analysis, visualization, and data store. The data exports cloud to the service. Results at the results integrated the enterprise server or data warehouse. So what we are doing here is, So consider you have this is the how can we export, or how can we uh, export to the cloud services. So the data from the database management, you have two types. One is the process is divided into data store and then cloud service. So this is one part and this is another part. Here first what we will do is we will get the data and we will explore that to the cloud. Here in data store, first we do data mining and data analysis, and data reports is done, reports and visualization is done. And in the clouds, data ports, so we data analyze, machine learning, everything will be done. And big data port will transfer to the big data port, and from both of this data is integrated in data warehouse and enterprise or enterprise services. So the data from the database management or data from the cloud service provider will be integrated in the data service or data integration with the help of enterprise server or data warehouse. So now moving on to the next concept, that is data store export from machine files computer web service to web servers to the machine. So how can we transfer the data from the machine to the web server or web browser or web service? How can we transfer the file from the machine? So in the machine you have in the machine data export, first you have a cloud service. With the help of cloud service you can easily access or export the data to the store and pre-processing. So from the web server or the web browser, with the help of cloud service you can export the data store. So how can we with the help of cloud service, how can we do that? We have a different services provided by the cloud, that is IaaS, PaaS and then SaaS. With the help of this services, we can easily export the data from export the data store after pre-processing or of data from the machine and file data sources. And so we can export it from the computer, web server or even web services, or even from the machine with the help of three services, that is SaaS, PaaS and then IaaS. So that is how it is done. And moving on to the next concept, that is data storage and then management. Here we are comparing the data storage and management of the traditional system and then big data analysis. So traditional system, as I said, it's related to the SQL or RDBMS, whereas big data is nothing but a very huge NoSQL storage of data. So first start with the SQL. So traditional, it's nothing but a semi-structured or unstructured data. So the sources of structured data is nothing but RDBMS, MySQL, enterprise server or data warehouse. These are all the sources where we can get this traditional system. And here in traditional system we learn about SQL, that is structured query language. Here we can do create, update or delete operations. We can create a schema, create catalog, we use the data definition language, and even we use data manipulation language, and we use a data creation control language. So that is DCL, data control language, is also used. And the next we have another one traditional system, traditional data storage, that is distributed database management system, that is DDMS here. So I said distributed computing. Distributed computing is nothing but two different computers working together to achieve one single task. Similarly, in distributed data management system, collection of logically interrelated database at a multiple system over computer network, that is nothing but the distributed database management system. Collection of locally related database is used. And the next, so we have another types, that is in-memory column formats and in-memory row formats. Here row oriented will be there, here column oriented will be there. Here we use OLAP, here we use OTLP. And the next, enterprise data or the services. Here we use the data from the several distributed sources using so here several distributed sources which store data using a various technology. So we use the merge using integration tool. We merge the data using integration tool, and collective weaving or data set at the data warehouse is done. So how can we weave this data set? We weave this data set at the data warehouse, and Yeah, so this is not that much important. So now we have learned a traditional system. Now we are moving on to the big data storage. In big data storage, you will learn about NoSQL. NoSQL is nothing but not only SQL. Here semi-structured data will be used, and do not integrate with the application using SQL. So NoSQL is also used in cloud data store, and features of this NoSQL is as follows. Yeah. It's a non-relational data storage consisting of uninterrupted key value pair, that is a big hash table, and unordered keys, and using a JSON. So ordered keys and semi-structured data storage system. Cassandra is used. Do not use as a joins, and data written at one code and replicate at a multiple nodes. We may relax ACID properties during this big data. So this is nothing but various data source and example and usage. Relational analysis, NoSQL. These are all the various data source. Hadoop clusters, web application, cloud data, individual data, and etc. So this is nothing but the different various data source. So here coexistence of relational database with the traditional server system, that is NoSQL. So Hadoop distributed file system, we use a Spark, big data stack, high volume or terabytes of data. We use ODS and operational system, documents image is used, and ODS operational system we use this high volume data, and traditional RDBMS uses the data warehouse and computing logos, and then enterprise server. So big data platform. Big data platform. So big data platform supports the large data and volume data. The data generate at a high velocity in more varieties or in a more veracity. So big data platform should provision the tools and services for. So there must be tools and services for the following properties, that is for storage and processing and analytics, developing, deploying, and then operating, and even reducing the complexities and custom development, and even the traditional as well as the big data technique. So these the tools for these features must be present in the big data platform. And big data storage and analytic depend captured at the companies, and require the following services, require the following. So data management, storage, and analytic of big data captured data companies and the services require the following. What they require? So new innovative non-traditional data, distributed data stores, creating a scalable huge volume of data, massive parallelism, high speed network, high performance, high data management. So in-memory data, data retrieval, etc. These are all the various features are there. So that is required at the companies, and the services require the following properties. So moving on to the next, we can learn it on its own. So you just need to memorize these points. And moving on to the next concept, that is Hadoop. So here you have Hadoop big data environment, or Hadoop big data Hadoop distributed file system. So here you have Hadoop distributed file system, data warehouse, and then data operational data store. So Hadoop is dependent on the MapReduce concept. So that is shown here, and document and images will be used by this, and high volume will be uses the Hadoop distributed file system. And the next one we have big data stack. So here it's explaining about the big data stack. Stack goes like this: storage, services, processing, NoSQL, and then MapReduce. So these are all the tools for big data environment. So storage, so the tools used for the storage is Hadoop distributed file system. Servers, we use Amazon S3 or ECZ, EC2 or ECZ. Or processing, we use Spark, IBM, and NoSQL, MongoDB, Apache Cassandra. And MapReduce, Apache Hive, Apache Pick, cascading, and etc. These are all the tools for big data. And the next, big data analytics. So in big data analytics, so defined as the statistical or mathematical data analysis that clusters, segments, rank the predicts future possibilities. So here what we will do is statistical and mathematical data analysis that cluster, segment, and ranks predicts the future possibilities is done. So that is nothing but a big data analytics. So there are various features or the various phases in analytics. That one is descriptive analytics, predictive analysis, and prescriptive analysis, cognitive analytics. So we have different phases. So here we have a different new facts. Analytics has the following phases before deriving a new facts, providing the business intelligence and generating the new knowledge. So the first phase is the descriptive analysis. This is helpful in deriving the additional value from the visualization. And the predictive analysis, which enables extraction of new facts and knowledge. And next we have prescriptive analytics. So here enable derivation of additional value and then undertake the better decision for new option. Cognitive analytics enables the derivation of additional value and undertake the bigger decision. So these are all the four phases of the big data analytics. The first one is descriptive analytics, predictive analytics, prescriptive analytics, and the cognitive analytics. So this is a reference model. Here a traditional and then big data reference model is used. So first we have data visualization, OLP, and data access and traditional storage, and then storage source enterprise data. So that is given here. Big data analytics and intelligence is used. Analytics application support, organized data store layer, and sources acquiring. So this is the reference model, just a reference model. And the next we have Berkeley database, Berkeley data analysis stack, that is BDAS. So it consists of data pre-processing, data management, and resource management layers. So this is also one of the type of Berkeley data analytics stack. So data analytics stacks of the Berkeley. So it has data pre-processing, data management, and resource management layers. So this has a following list of application, data processing, and resource management. So yeah, application AMP and Carat run at BDAS. Data processing software component provides the in-memory processing, and data processing combines batch and streaming interactive. Resource management components provides the sharing and then infrastructure. So that is nothing but the properties of BDAS. So the 4-layer of architecture of BDAS, that is Berkeley data stack, is given here, that consists of the Hadoop. So Hadoop yarn is used, Hadoop distributed file is used, Spark, that is processing engine, and Apache SQL as an application engine, and Hadoop distributed file for the data storage, Hadoop yarn for parallel task. So this is the 4-layer architecture of big data stack consisting of Hadoop and MapReduce and Spark and Core. So, and moving on to the next, that is the important question, that is big data applications. So the big data is used in big data marketing and sales, detection of marketing frauds, and big data risk, and big data credit card risk management, and big data in the Hadoop big data in medicine, and big data in advertising. So these are all the application where we can use this big data. So first one is most important aspect of marketing and sales. So quality, services, and price is used, and you can read this on your own, because big data analytics in detection of fraud. So these are the following feature for enabling the detection prevention frauds. So we use these following features in order to detect or enabling the detection prevention frauds. That is fusing of existing data, using of multiple source of data connecting, providing a greater insights using a querying, analyzing data, provides a higher volume data mining. So this is nothing but big data analytics. And the next, data risk. So big data provides an avoid the data risk. So even it will helpful for identifying the credit card risk and helpful in managing the risk. So that is following, it will do the following task, that is it identifies the high credit rating, identify the risk involved before lending, identifying industrial sectors, identifying the type of employees, anticipating liquidity issues. So these are all the different types of properties will be done. And in healthcare, it will do the following facilities: provisioning of value-based customer-centric healthcare, and usage of IoT, and preventing the fraud, waste, abuse in the healthcare industries, improving the outcome, monitoring in the patients in real time. That is done with the help of big data analytics and big data in medicines. So develop a large volume of data to identify and deliver the intelligence using the predictive model about the individuals. Following are some of the findings: building a health profile of an individual patient and predicting model for diagnosing the better and offer better treatment. So that is used in the big data medicine. And advertising. So impact of big data on the is also on the advertising industry. Sends advertisement using SMS, emails, WhatsApp, LinkedIn, and Facebook, Twitter, and even other mediums. So big data captures a multiple source in a large volume, velocity, and variety. So it will provide an emerging trend and patterns and things of identifies or analyzes the customer, and then it will send the advertisement. So that there also we can use this big data. So these are all the advantages of, or the application of the big data. So this is about this module. So let me just sum up. Here you just learned about the need of the big data and what is this web data, and different types of data, that is structured, semi-structured, multi-structured, and unstructured. Definition of big data and characteristic, that is 4 V's, and types where we can get this big data. And the next data classification, big data classification. And next you have handling techniques and scalability and parallel processing. So cloud computing features or the services provided by the cloud, and volunteering, and data architecture design. So this 5 layers is important. And so managing the big data analytics, and moving on to the next concept, that is data quality. About how can we improve the quality of low quality data. So how can we export data to the cloud, and how can we export data from the machine files. So that is about it. And data storage and analysis. Here we have compared a traditional method with the big data analytics, that is we have learned regarding SQL, BMS, and NoSQL. So that is big data storage. And we have learned regarding a big data platform, how it should be and the properties of that, and Hadoop file system. So big data analytics, 4 phases, and Berkeley data analysis stack, and big data applications. Here we round up this module. Thank you. Stay tuned for more videos.